Good morning and welcome to Teekay Services. So this is going to be my second and the last video that I'm going to push for people who are interested to sign up to my CFA Level 1 curriculum for students who are wish to appearing in the June 2020 examinations. And the topic that I'm going to do today is tell you about the fixed income securities. We'll start with bonds, and I'll tell you about the yield to maturity and the relationship that it carries with price, and how can we calculate this yield to maturity using the Texas BA2 Plus calculator as well as Microsoft Excel. So let's quickly start by demonstrating to you the relationship that exists between bond yield and bond prices. So this diagram will make this absolutely clear for you. So as you can see, this is actually a seesaw, and in this seesaw, on one side there is yield and the other side there is price. Now what does this demonstrate? This means that when the yields are rising upwards, this is going to push the prices downwards, and when the yields are plummeting downwards, it is going to push the prices upwards. So you can see that there is an inverse relationship that exists between bond yields and the bond prices. The question is, why does this inverse relationship exist? Before you kind of understand that relationship, you must take a hypothetical example which will make this absolutely clear for you. So let me first take an example for you. Here we go. So let's start with a bond, let's say, which has a face value of $1,000. Okay, a bond with a face value of $1,000. There are 3 years to maturity. It carries an annual coupon of 8%. Okay, and the minimum expected yield from this particular bond is, let's say, for the investor it is 10%. Let's quickly put this in the form of a timeline. Okay, you are currently standing here, and as I always mention, this is time 0. At the end of year 1, you are expecting your first cash flow, which is the first coupon C1. At the end of year 2, you are expecting your second cash flow, which is C2. And at the end of year 3, you are expecting your third coupon C3 plus the face value of the bond. Okay, let's try and first also put the values to these particular coupons. Now, given that this is a $1,000 par value bond and the coupon is 8%, you should expect $80 as your coupon payment at the end of year 1, another $80 as your coupon payment at the end of year 2, and the cash flow that you will expect at the end of year 3 will be $1,080, because you will be getting your face value of the bond back plus your coupon of 8%. Now, mind you, you are currently standing here expecting a minimum 10% of as a yield, and the cash flows that are occurring are at the end of year 1, year 2 and year 3. Now you want to make an investment at this point in time, which is time 0, and you want to decide what is the best possible price that you're willing to pay for the bond. The estimated cash flows are 1 year, 2 years and 3 years down the line. So for you to make an informed decision, you will have to pull back these cash flows in time. So the first year cash flow you will pull back by 1 year, the second year cash flow by 2 years, and the third year cash flow by 3 years. What we will do is we will try to find out what is the present value of these 3 cash flows. So the present value of the first year cash flow will be, which is your $80, okay, divided by 1 plus r to the power of n. In this case it will be 1.10 raised to the power of 1. What we will do is we will use your Texas BA2 Plus calculator to find out the yield. Before you start using the Texas BA2 Plus calculator, always reset. How will you reset? Press second, reset, enter, and then you put it to 4 decimal places ideally. So press second, format 4, enter. You will have your Texas BA2 plus calculator taking 4 decimals as appropriate. What I am going to do is I am going to find out the present value of the first year cash flow, which is 80 divided by 1.1, which is $72.7273, and I'm going to put that here, $72.7273. The present value of the second year cash flow will be how much? The present value of the second year cash flow is $80 divided by 1.10 raised to the power of 2, because here we are going to pull this back by another 2 years. So divide this by 1.10 square and you get the second year cash flow present value, which is 66.1157. And now what we are going to do is we are going to find out the present value of the third year cash flow, and the present value of the third year cash flow is $1080 divided by 1.10 raised to the power of 3, which is 1.10 raised to the power of 3 1 by x into 1080, which is 811.42. So I'm going to write here 811.42. Now I'm going to sum this all up. Present value of the first year cash flow plus present value of the second year cash flow plus the present value of the third year cash flow, and I am going to get what? I am now going to put this in a different color. You are going to get 66.1157 plus 72.7273, which is $950.263. So you are actually looking at paying not more than $950.263 for investing in this bond. Do you have an observation here, ladies and gentlemen? I do have an observation. Please look at the coupon carefully. The coupon was 8%. Can you see this? And your expected yield from the investment in the bond is 10%. Do you see that the yield has actually surpassed the coupon? Yield has exceeded the coupon, which has actually pushed down the price, and you will see that the bond is currently trading at a discount. So let me write this for you. In this case, we saw that the yield has exceeded the coupon and therefore the bond is trading at a discount. This was your first learning observation when you are comparing the yield and the price and studying the relationship between the yield and the price. We will repeat the same example, but this time the yield will be lower than the coupon rate. Let's try and do it. Now let's try and see the same example, all numbers remaining the same, just that instead of expecting a 10% yield on your investment, you are an investor who is expecting 6% yield. The present value of the first year cash flow will be therefore $80, which remains unchanged. Now mind you, your coupon never changes. Your coupon is going to be the same. The face value doesn't change. The coupon rate does not change. So that remains the same, and your yield changes, and therefore you're going to discount at a different rate. So present value of the first year cash flow will be 80 by 1.06. The present value of the second year cash flow, ladies and gentlemen, will be $80 divided by 1.06 raised to the power of 2, and the present value of the third year cash flow, here we go, is going to be $80 divided by 1.06 raised to the power of 3. What we will do now is use the calculator and find out what these values are. I will again reset the calculator in the method described to you. 80 divided by 1.06 will be 75.4717. So the present value of the first year cash flow is $75.4717. The present value of the second year cash flow will be $71.1997. So I will write this $71.1997, and the present value of the third year cash flow is going to be, just 1 second please, let me just do it on my calc. You can also do this simultaneously. You get 906.7888. So I will write here 906.7888. Now we will sum this all up and see what is the expected price that you are willing to pay today for the bond. I'm going to add this all up and see what I get. You also please do it simultaneously. Plus 75.4717, so you get $1053.4602, and I'm going to make a note of this here, $1053.4602. Now ladies and gentlemen, do you have an observation again here? I do have an observation. What is that observation? Now did you see here that in this particular case the coupon was 8%, but the yield was 6%. So you saw that the yield is less than the coupon. The yield has gone below the coupon, and because the yield has gone below the coupon, the prices have shot up, and you will see that the bond is actually trading at a premium. Okay, this again validates for you the inverse relationship that exists between the bond yield and the bond price. What I am going to do now is I'm going to put this down in a small matrix so that it's absolutely clear for you to understand. So what did we observe? We observed that when the yield to maturity, in the first example, the yield to maturity was more than the coupon, the bond was trading at a discount. In the second example, what did we observe? We observed that the yield to maturity was below the coupon, and we observed that the bond is trading at a premium. And you will observe that when YTM is equal to your coupon rate, that is when the bond trades at par. So this matrix kind of summarizes for you the relationship that exists between the YTM and the coupon, and you can see also how this relationship is self-validated. When the YTM is exceeding the coupon rate, the bond prices fall down and the bonds trade at a discount. When the YTM falls below the coupon rate, the bond prices rise and the bonds start trading at a premium. This example kind of helps you to understand the inverse relationship that exists between the bond yield and the bond price. And mind you, we have also used this relationship to price the bond. We priced in both circumstances, if you remember. Now what I'm going to do is I am going to help you use the Excel later and first the Texas VA2 Plus calculator to first find out the YTM of the bond. So what you do, guys, first please pick up the Texas VA2 Plus calculator. What you should do is please type 1053.4602, put a minus sign, and I will tell you why we put a minus sign, and press that as PV. PV is the present value of the bond. So I repeat, minus 1053.4602, type that and press PV. Then please type 3 and press that as N, and then please type 1000 and press that as FV. Okay, press 80 or type 80 and press that as PMT. PMT is your recurring payment, in this case coupon, and then press CPT or compute and press I by Y, which should actually give you your yield. Now let me also do this simultaneously for you and see what I get. So I'm going to do this first. I'll type 1053.4602 as I told you, minus 1053.4602 minus as my 0.4602 minus as my present value. 3 is my years to maturity. I press this as N. 1000 I type and I press this as my future value. 80 I press this as my payment. I press compute I by Y, and you will see you get a yield to maturity of 6%, because I by Y is the measurement of yield. In this case, the annual yield works out to be 6%. So we just use, what did we do? We first anticipated a yield of 6% when we were doing the premium example, and we found out the bond price. So what did we find out as the bond price? We found out that the bond price was 1053.4602, and we established that when the yield fell below the coupon, the bond was trading at a premium. Now we use the same data. We use the bond price, we use the years to maturity, we use the face value, we use the recurring coupon payment, and we found out the yield using the Texas BA2 plus, and we got rightly the interest rate or the yield as 6% we had earlier used in our example. So we also did the reverse thing using Texas BA2 calculator, and using this calculator we were able to fetch or calculate rather what is the estimated yield to maturity in case of a bond. Very useful in finding out YTM for a bond. Let us now quickly also do this for a particular bond in case of Microsoft Excel. I don't know if you're aware, but there is a particular solution that Excel can also give to validate your results, and this is called the rate function. So let's use the rate function is equal to rate. There are 5 values that you need to enter here. The first one is N per. N per basically means the number of periods remaining to maturity. In the case of our example, this is 3 periods, so we write 3. PMT is basically the payment, which is the recurring payment. In our case, that is the coupon of $80. PV is the present value of the bond. Please note that I will write here minus 1053.4602. The reason we write minus 1053.4602, the reason we write minus and we use the same thing in case of Texas BA2 plus also is because the system needs to understand a give and take relationship. Minus suggests that you're investing in the bond now by buying the bond at a price of $1,053.46, and plus suggests that you're getting the principal or the principal value or the face value of the bond back after maturity. So for future value we write plus 1000. The type of the bond we will write 0, because 0 type will basically suggest that the bond makes coupon payments at the end of every period, and you will see that you will get back the same in yield to maturity, which is 6%, which basically tells you that the calculated yield to maturity was absolutely correct. Okay, so this basically and this is the screen which tells you what we had done via using the Texas BA2 plus calculator. That also gave you 6%. The Excel also gave you 6%, which basically tells you that you can replicate the same results using the Texas BA2 plus calculator as well as the Microsoft Excel. So just to summarize, what did I teach you in this quick small tutorial? I told you what is the relationship between the yield and the price. It is an inverse relationship. How do we price the bond? What happens when the YTM is below the coupon? What happens when the YTM is more than the coupon? When the YTM falls below the coupon, the bond trades at a premium. When the YTM exceeds the coupon, the bond trades at a discount. I also told you how to calculate the YTM using Microsoft Excel, and most importantly using the Texas BA2 plus calculator. I will just end this tutorial with a small definition of YTM. Yield to maturity is basically the yield that an investor can expect if he holds the bond till maturity and if the coupon and the principal payments are paid on time. And in a nutshell, yield to maturity will equate the present value of all cash flows with the current price of the bond. With that, I end this tutorial. I hope you enjoyed it, and I do hope that you will sign in to my CFA Level 1 preparatory course for the June 2020 examinations. Thank you very much and wish you a very happy preparation.